Greetings and welcome. This is Dr. B.D.Y. Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be learning about the tutorial question bank in impulse momentum and mechanical vibrations. The tutorial question bank, which was provided with the Engineering Mechanics course, the module 5 of the Engineering Mechanics course is impulse momentum and mechanical vibrations. In this module, we are going to see some of the important problems that are in the tutorial question. Before starting the problems, let us first recollect what the impulse and momentum equation is. We have already taken a consideration that impulse is treated as product of resultant force into time, which is equal to change in momentum. So, the R and T, the product of R and T, this is treated as the impulse. And whatever force that is R is the resultant force in the system. So whatever number of forces may be acting in the system, the resultant of that particular force, all the system of forces, the resultant of the system of forces is the resultant force, and product of this force with the time. This T is the time. So this time is the time to which the force is applied in the system. So the resultant force that is being applied in the system with respect to time, that time is being treated as T. So the product of this resultant force and the time gives the impulse. And this equation is equal to the change in momentum. We know that the product of mass and velocity is momentum. So, the product of mass and velocity is momentum, and this change in momentum, that is the final momentum minus the initial momentum. The final momentum minus the initial momentum is the difference which we are taking, the change in the momentum, that is the final momentum minus initial momentum is treated as the change in momentum. So the impulse momentum equation is given as the impulse is equal to change in momentum. This is the impulse momentum equation, and related to this equation we are going to solve the number of problems. And there is another important term or topic in this impulse momentum equation which is related to impact. So the impact or collision, which we call the impact or collision of bodies or elastic bodies that we are considering, is another term, important term in this impulse momentum equation, wherein we are going to take the conservation of momentum principle. So the conservation of momentum principle which is being treated as, for example, there are number of forces that are acting in the system and the system is being displaced, or there is some difference in status of the bodies that are in the system is happening. Then the conservation of momentum is stated in a way that if the resultant of the total system considering prior to the status and after the status, in the simple terms we can consider it as before action and after reaction. We all know, according to the Newton's third law, for each and every action there is an equivalent opposite reaction. So, if we consider a system wherein there is some action going on, let us say some application of the force or some impact that is happening in the system, and this is equated to the reaction. That means because of the action that is happening, whatever reaction that is being seen in that system, both should be considered combined. So the conservation of momentum, that is conservation of momentum, is considered only when the total system is considered. That means the before action and after reaction points are needed to be considered at a time. So total system is being considered, then only we will be achieving this conservation of momentum. We will not achieve the conservation of momentum when individual object or individual action or reaction is being taken care. So the complete action and reaction in the system needs to be considered at a time. Then only we are going to get the conservation of momentum principle acting. So for this to happen, the resultant in the system needs to be zero. So simply we can say that the system is treated as conserved. So the momentum in the system is treated as conserved when there is no resultant. That means the resultant force is zero. So as per our resultant force, that is the impulse momentum equation which we have taken, R into T is equal to mv minus mu. In this, if this resultant force term, that is the resultant is zero, then what happens? This entire LHS becomes zero. So we can write 0 is equal to mv minus mu. That means if we take this negative term to the other side, we will get initial momentum is equal to final momentum. So whatever momentum that we are going to see in the system before action, that is this m into u, is equal to this m into v. That means after reaction. So here when we consider this conservation of momentum, then when we see the total system, then the initial and final momentums will be equal. So that will be considered as the conservation of momentum. So with this also we are going to solve the number of problems. And another term here would be the spring constant or the simple harmonic motion. Or here in the impulse momentum equation, we will be considering the collision. So in this collision, we are going to see the recoil of gun. So recoil of gun is defined as what the negative direction force that is being impacted because of the firing that is taking place inside the gun. It is called the recoil of the gun. The reverse movement of the gun, which happens because of the firing that is being taking place in this gun, is called as the recoil of the gun. And this recoil is the result of the impact which is being seen inside the barrel of the gun because of the firing. When firing happens, the bullet is being kicked out into the barrel through the barrel, and bullet comes out of the barrel with some velocity because of the firing. This impact, because of this action, the reaction which is being seen in this recoil of the gun is the reverse movement of the gun, that is opposite direction movement of the gun to the direction of the bullet. So this is called as the recoil of the gun. When we consider this recoil of the gun, again there will be coefficient of restitution that is being seen in the collisions, impact of or collision of elastic bodies, and this coefficient of restitution, which is treated as E, will be taken care, or it will be considered for the evaluation of the problems. So this coefficient of restitution again is the result of the case which we are going to see because of the Newton's third law. So this is about the basics of this impulse momentum equation. So now let us go to the problem. problems, the important problems that are seen in the impulse momentum equation. The first problem given is a marble, that is a glass marble, whose weight is 0.2 newtons, falls from a height of 10 meters. That means a glass marble, a small glass ball, we can say that the children used to play, the glass marble, it is being thrown from a height of 10 meters. That is, we can consider this falls from a height of 10 meters as the freely falling body. That means we have taken this marble to a height of 10 meters and we have left it. So when we leave the marble from the height of 10 meters, it is falling from a height of 10 meters and the weight of the marble is given as 0.2 newtons. So the distance to which the marble is traveling is 10 meters. So the case which is given in the problem is a glass marble whose weight is 0.2 newtons, falls from a height of 10 meters and rebounds to a height of 8 meters. That means it again jumps back into the air to a height of 8 meters. Right? We know that this is the cause because of the action which is happening. So the action is, in this system, the action is traveling of the ball, that glass ball, to the ground from a height of 10 meters. When it touches the ground, there will be some impact. So glass will be touching the ground with some force, with some impact. And this impact will be continuing to a fraction of second or a small interval of time. So that interval of time is given here as 1/10 of a second. Then find the impulse and the average force between the marble and the floor. So whatever marble is getting in contact with the floor to a small interval of time, at that particular small interval of time, we need to identify the impulse, that is the force into time, and the average force between the marble and the floor. And if the time during which they are in contact is 1/10 of a second. So the time to which the marble is getting into contact with the floor is given as 1/10 of a second. That means 0.1 seconds. So this is the problem given, and now we need to identify the impulse of the system and we need to give the force, average force that is being applied into the ground. So if we draw the concept of this given problem, it will be like this. So here what we are considering, point A is the starting point or the point from which the marble is being left in the air. Then it is traveling to a distance of 10 meters from the air and it is getting in touch with this ground at this point. Then after touching or getting into contact with the ground, the reaction what is happening, this ball, this glass marble again comes back up into the air to a distance of 8 meters. So that 8 meters we are considering as point B. So overall, we need to identify the impact, the average force that is being acted upon this point. So for doing this, let us start the problem. For freely falling body, the velocity with which the body strikes the ground, right? There is an equation that is V, that or U, that is the velocity at the contact point of the ground, is given as under root 2gh. So this is the velocity when the marble touches this ground. So after traveling from certain distance or point A, at point A, the velocity will be 0, isn't it? At point A, the velocity, or we can get it as velocity is equal to 0. Once it starts traveling in the air or coming to in the direction of the ground, it achieves some velocity. It will achieve some velocity. So, at the contact point of that marble to the ground, there will be certain velocity. The contact point, if at all there is no restriction, the marble is stopped here because of there is a restriction of the ground to the direction of travel of the marble. If at all there is no restriction, if there is no ground, then what happens? It will continue to come down again, isn't it? So, the traveling in this travel time, there will be some certain velocity, and that velocity gets increased as this traveling happens. So, as at this point, when there is a restriction, whatever velocity that is the marble is having, that velocity is given with the equation under root 2gh. So, when you substitute the values in the given equation under root 2gh, we can see that the g value is 9.81 and the height to which the marble has traveled, that is the distance is 10 meters. So, overall the value would be 14.007 meters per second, and this is traveling in downwards. That's the reason the velocity is given in the downward direction. So, here the downward direction velocity at this point is taken as 14.007 meters per second. Now, if we consider the velocity with which the body rebounds, that means the velocity at the same point, the starting velocity for the rebound of the object, that is the marble, right? There would be some velocity at this point. Why? Because with some velocity, the object should start to move, right? So, as there is some impact that is happening here, that is happening at the ground, the starting velocity in the opposite direction, that is upward direction, is taken as v, that is upward direction velocity, and again at the same point we can consider that as under root 2gh, and this time the value of h would be 8 meters because it has travelled to a distance of 8 meters. So, in this way, we will be getting the value as 12.528 meters per second, and this velocity is the upward direction. So, now here we can consider this at the same point. At the same point of contact, we are able to see two direction velocities. At the same point, the downward direction velocity is obtained as 14.27 meters per second, and at the same point, the upward velocity is being obtained as 12.528 meters per second. Right? So, at the same point, depending on the direction of the marble travel, we have got two velocities. Now, taking upwards as positive and applying equation, impulse is equal to change in momentum, that is mv minus mu. Here what we are considering, the upward travel we are considering as positive. So, whatever downwards movement or downwards direction it is, that would be negative direction velocity we will be considering. Right? So, as per the discussion, when we substitute the equation, that is impulse is equal to change in momentum, we will be getting it as w by g. That means from this we are getting m into v minus u, and this m, mass, can be written as weight by acceleration due to gravity. Hence that equation is obtained as w by g into v minus u by v minus u. So, when you substitute the values, that is weight, that is given as 0.2 newtons, and the value of acceleration due to gravity, that is 9.81, and the initial velocity or final velocity, that is v, in the upward direction, velocity in the upward direction, that would be the final velocity, that is 12.52 meters per second, and minus into minus 14.007. Why it is been given as minus here? Because we are considering the upward movement is as positive and this velocity is related to the downward. So we are considering it as negative velocity. So in this way, we have obtained the value of 0.541 newtons second. So the impulse is taken as force into time. That's the reason it would be 0.541 newton second. And this is the average force. For identifying the average force, what we can obtain is F into T is equal to 0.541. That can be taken as F is equal to 0.541 by 10. So from this, we can obtain F as 5.41 newtons. Here, the resultant force, that is F into time T, is given as 0.541. Hence, the whatever value that we have obtained here, that is taken here, and then from this we can get the force that is being applied in the system as 0.541 by T. In this way, we have got the value of the average force that is being acting in the system as 5.41 newtons. So this is how the problem is solved. Now let us go to the next problem. So the problem given here is a 1500 Newton block is in contact with a level plane. So let us see the figure. The 1500 Newton block that is given here, it is in contact with the level plane. This is the plane on which the block is in contact. The coefficient of friction between the two contacting surfaces being 0.1. So the coefficient of friction value that is given as 0.1. Then if the block is acted upon by a horizontal force, this 300 newtons, what time will elapse before the block reaches a velocity of 16 meters per second? See, starting from the rest. So as per the given condition, initially the block is at rest. So afterwards what happened? There is an application of 300 Newton force in the right hand side direction. So obviously, because of this force that is being applied onto the 1500 Newton block, this block will move in the right hand side direction. It will start to move. Once it is getting to start to move, then the question being asked is, what time will elapse before the block reaches 16 meters per second speed or velocity? That means we need to calculate the time at which the velocity of the block would be 16 meters per second. Then, if 300 Newton force is then removed, that means once the block reaches 16 meters per second speed, then this 300 Newton force is removed. How much longer will the block continue to move? So after the removal of the force, 300 Newton force, what happens? Because of the momentum, the block will continue to move. Even though the block is moving, there is some friction that is being acting between the contact surface, that is here on the level plane. So what happens? After certain distance, it will get to stop. That means again the block will come to rest. So here it is being asked that when will the block will come to rest? After the removal of the force of 300 newtons. That is the second question. Or we can consider it as second case. Now, solve problem using impulse momentum equation. So it is being asked to solve this problem using impulse momentum equation. So let us start the problem. If we draw the free body diagram of this particular case, what is happening? In the first case, there is a 300 Newton force that is being applied onto the 1500 Newton block. So weight will always be shown in the downward direction, vertically downward direction, and removal of this reaction, or we can say it as the support, we are showing the frictional force that is being acted in the left hand side direction. Why? Because the object is moving in the right hand side direction. Frictional force always acts opposite to the direction of the movement of the object, right? And then N is the normal reaction that is acting towards the object. So this is the free body diagram of the given system. Now, from the free body diagram, we can obtain sigma Fy is equal to 0. That means if we apply all the horizontal forces is equal to 0, then this is the condition of equilibrium where we are going to consider all the vertical forces, that is this 1500 newtons vertical force and this normal reaction vertical force. There are two vertical forces acting in the system, and we are getting the information about the sigma Fy is equal to 0. That is the equilibrium condition wherein all sum of all vertical forces is equal to 0. So there are two forces, hence we are writing it as N minus 1500. Why this negative symbol is taken? As this weight is acting in the negative axis direction. Hence it is taken as minus 1500. Now, if we solve this, it is N is equal to 1500 newtons, we can say. So, this N normal reaction value we have obtained. We also know that mu is equal to F by N. That means F is equal to mu into N. So, mu value is already given as 0.1 and N value we just have obtained as 1500. So, if we apply the system, that is F is equal to 0.1 into 1500, we will get the value of F as 150 newtons. So, in this way, when we have applied sigma Fy equation, condition of equilibrium, we have obtained the value of F as 150 newtons. Now, the reaction force, that is, if we consider all the horizontal component forces is equal to 0 condition, we can get, there are two equations, that is 300 Newton and this friction 150 Newton horizontal forces. If we apply the reaction force in the system, whatever it is happening, the total system, it would be 300 minus 150. When you solve this, applying impulse momentum equation, we will get the impulse momentum, that is impulse resultant force or reaction force into time is equal to W by G into V minus U. So, we have got the final velocity as 16 meters per second. That is what been asked in the question. And the initial velocity is 0, which is it. Why? Because the object is starting from rest. So, when you continue this, you will get the value of time t as 16.31 seconds. Now, as the second case, when force is removed from the body, that means once the speed of 16 meters per second is achieved, the second case, what is happening? We are removing the force of 300 newtons. So, ultimately, from the reaction force, if 300 Newton force is removed, then it would be left with minus 150. So, when we apply again this impulse momentum equation for the second case, we will be getting minus 150 into t is equal to 1500 by 9.81, and this is final velocity and initial velocity. So, in the second case, what is happening? Already the block has achieved a speed of 16 meters per second. So, that would be the initial velocity, and after traveling certain time, again the block will come to rest. That means the final velocity would be 0. Hence, it is taken as 0 minus 16. In this way, when you solve for this, we will be getting the value of t as 16.31 seconds. So, we have obtained the value of time at which the object will come to rest. So the block takes another 16.31 seconds before it comes to rest. Now let us go to the next problem. The problem given is a block weighing 130 newtons is on an incline. Let us draw the figure to this. So this 130 Newton block, it is on an incline whose slope is vertical 5 to horizontal 12. So the inclination of this plane, inclined plane on which the block is placed, it is been given in the form of 5 vertical to 12 horizontal. So the representation would be taken like this. Then its initial velocity down the incline is 2.4 meters per second. So it is traveling in the downward direction down the incline, and the initial velocity is given as 2.4 meters per second. Then what will be its velocity after 5 seconds? And take coefficient of friction at contact surface is 0.3. So if we draw for this case the free body diagram, it would be like this. So this is the body, and the whatever weight that is block is having, that is 130 newtons, it is acting vertically downwards, and this vertically downwards force will be a non-formal force for the inclined plane condition is taken. So what we need to do, we need to convert this vertical force which is not formal to its mutually perpendicular forces. So it is being taken as along the plane direction force and normal to the plane direction force. So these components would be 130 sine and 130 cos. So when you take the angle condition here from the given data and the figure, we can calculate the angle tan theta as 5 by 12. So it will give theta is equal to 22.62 degrees. Then sigma Fy is equal to 0. If we consider all the along the plane and normal to the plane condition is equal to 0. Here we are considering perpendicular to the plane forces is equal to 0 condition. Then it will give the value of n minus 130 cos 22.62 is equal to 0. Here the vertical or perpendicular to the plane forces are this normal reaction n and 130 cos 22.62 degrees. These two are the perpendicular to the plane forces. So that would be equal to, that will provide our normal reaction value n as 120 newtons. Now we have F is equal to mu n, that will give the value of frictional force F as 36 newtons. Then the reaction force R is equal to W sin theta minus F. So if we consider the summation of all the along the plane direction forces is equal to 0, it will be taken as W sin theta minus F, that is equal to 130 sin 22.62 degrees minus 36, that is equal to 14. Why we are considering this as minus? Because this F is being taken in the opposite direction and this 130 sin 22.62 degrees is taken as positive. So the reaction force we are considering like this. Then applying impulse momentum equation, R into T is equal to W by G V minus U. So when we substitute the values, R as 14 into 5 as the time given is equal to 130 by 9.81 into V minus 2.4. So with this, we can get the value of V as 7.68 meters per second. So now let us go to the next problem. So the problem given is a 800 Newton man moving horizontally with a velocity of 3 meters per second jumps off the end of a pier into a 3200 Newton boat. Determine the horizontal velocity of the boat. If it had no initial velocity, if it was approaching the pier with an initial velocity of 0.9 meters per second. So here also there are two cases. One is before and after action and reaction. So let us start the problem. The problem, the given data, weight of the man as 800 newtons and velocity of man as 3 meters per second. So we can consider the weight of the total system after the man jumps into the boat as 800 plus 3200, that would be 4000 newtons. Then initial velocity of boat is 0. Why? Because the boat is at rest. And for the first case, then initial momentum is equal to final momentum. We are considering the conservation of momentum here. So the value would be mass into velocity, wherein the man before jumping and after jumping we need to consider. So that man and boat, there are two objects in this total system, that is man and boat. So both man and boat before jumping of the person and after jumping of the person we will be considering. Hence we can write it as 800 by 9.81 into 3 plus 3200 by 9.81 into 0 is equal to 4000 by 9.81 V, which implies V is equal to 0.6 meters per second. So in the second case, what is happening? Initial velocity of the boat is 0.9 meters per second towards the pile. So as the man is traveling in one direction and the boat is coming in the opposite direction, we are considering the direction of the boat as negative velocity. Hence it is minus 0.9 meters per second. Now, applying principle of conservation of momentum, we can get 800 by 9.81 into 3 plus 3200 by 9.81 into minus 0.9 is equal to 4000 by 9.81 V. Hence, if we solve this, we will get the value of V as 0.12 meters per second. So the velocity of boat and man will be 0.12 meters per second towards the pile. Why? Because we have obtained the velocity as a negative. We have considered that the direction which is giving in negative is the towards the fire direction. Hence, we are taking it as 0.12 meters per second towards the fire. Now, let us go to the next problem. The problem is a car weighing 11,000 newtons and running at 10 meters per second holds 3 men, each weighing 700 newtons. The men jump off from the back and gaining a relative velocity of 5 meters per second with the car. Find the speed of the car if the 3 men jump off, first case in succession and second case all together. So we are considering the first case now. When the 3 men jump off in succession, that means one after the other, the men will jump off the car. So initial velocity would be u is equal to 10 meters per second. Hence the final velocity of car when the first man jumps, that is, we are considering the velocity as v1 meters per second, and the second man jumps, we are taking it as v2 meters per second, and when third man jumps, that is v3 meters per second as the velocity of the car. So the final velocity of first man would be v1 minus 5. Why? Because the relative velocity is 5 meters per second. So applying the principle of conservation of momentum, we will get 11,000 plus 3 into 700 into 10 is equal to 11,000 plus 2 into 700 into v1 plus v1 minus 5. So with this, if we solve 11,000 plus 3 into 700 into v1 minus 700 into 5. So we can take v1 is equal to 10 plus 700 into 5 by 11,000 plus 3 into 700 as equation 1. And the final velocity of second man would be v2 minus 5. So that would be 11,000 plus 2 into 700 v1. That is equal to 11,000 plus 700 v2 plus 700 v2 minus 5. So we can take v2 is equal to v1 plus 700 into 5 by 11,000 plus 2 into 700, taking it as equation 2. Now the final velocity of third man would be v3 minus 5. Hence, it can be taken as 11,000 plus 700 into v2 is equal to 11,000 v3 plus 700 into v3 minus 5. Then v3 is equal to v2 plus 700 into 5 by 11,000 plus 700. So this is taking it as equation 3. So from equations 1 to 20, we can get the value of v3 as 10.849 meters per second. Now as the second case, wherein all the men will be jumping together, the total weight of the men will be at a time deducted from the weight of the car. So it can be treated as 11,000 plus 3 into 700 into 10 is equal to 11,000 V plus 3 into 700 V1 minus 5. So with this, we can get the velocity V as 10.802 meters per second. Now coming to next problem. A gun of mass 30 tons fires a 456 kg projectile with a velocity of 305 meters per second. With what initial velocity will the gun recoil? If the recoil is overcome by an average force of 600 kilonewtons, how far will the gun travel? How long will it take? So this is the problem related to the recoil of gun. Now let us solve the problem. The mass of the gun is taken as capital M, that is equal to 30 tons. That means it is 30,000 kg. Then mass of projectile is small m, that is equal to 456 kg. So initial velocity of projectile is given as u is equal to 305 meters per second, and the velocity of recoil of gun is taken as v meters per second. Now from law of conservation of momentum, we can take mv minus mu is equal plus mu is equal to 0. So that can be taken as 30,000 into minus v, because that is the opposite direction movement, plus 456 into 305 is equal to 0. So that will give v is equal to 4.636 meters per second. Now consider the motion of the gun. The retarding force F can be taken as 600 kilonewtons, that is 6 lakhs newtons. Hence F is equal to ma. If we take, we can substitute the values, and acceleration A can be taken as 20 meters per second square. So also we know that v square minus u square is equal to minus 2as, as it is traveling in the opposite direction. That will give the value of s as 0.5373 meters. And v is equal to u plus minus 80. From this you can get the value of t as 0.23 seconds. Now coming to the next problem. A body of mass 2 kg is moving at a speed of 0.5 meters per second to the right, collides with a mass of 3.5 kg which is at rest. After collision, the 3.5 kg mass moves to right at a speed of 0.25 meters per second. Determine the coefficient of restitution. So here the conservation of momentum principle is used for identifying the coefficient of restitution E. If we apply m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, wherein m1 and m2 are the masses of the bodies, and u1 and u2 are initial velocities of body 1 and 2, and v1 and v2 are the final velocities of body 1 and 2. When we substitute the values, given values here, 2 into 0.5 plus 3.5 into 0 is equal to 2 into v1 plus 3.5 into 0.25, we will obtain the value of v1 as 0.0625 meters per second. Now the coefficient of restitution value, the equation is E is equal to v2 minus v1 by u1 minus v2. If we substitute the values, we will get the coefficient of restitution value as 0.375. Now let us go to the vibrations problems. Therein the problem given is the piston of an engine moves with simple harmonic motion. The crank rotates at 100 rpm and the stroke is 180 centimeters. Find the velocity and acceleration of the piston when it is at a distance of 60 centimeters from the center. So from the figure you can understand the crank rotation with a radius of 0.9 meters, it is being rotated, and the movement of the piston inside the cylinder, the top dead center to bottom dead center length, it is taken as 1.8 meters. So once the angular speed value, that is omega, is equal to 2 pi n by 60, if we calculate, the angular speed omega can be obtained as 10.47 radians per second. Hence the stroke length, that is L, is equal to 180 centimeters. That means it is 1.8 meters. Therefore the amplitude R is given as 0.9 meters. Then velocity of piston is given as Vx is equal to omega under root r square minus x square, that is equal to 10.47 under root 0.9 square minus 0.6 square, that is equal to 7.02 meters per second. Hence the acceleration of piston is taken as Ax is equal to omega square x, and that is 10.47 square into 0.6, that is equal to 65.77 meters per second square. Now coming to next problem. A body performing simple harmonic motion has a velocity 12 meters per second when the displacement is 50 millimeter and 3 meters per second when the displacement is 100 millimeter. The displacement being measured from midpoint. Calculate the frequency and amplitude of the motion. What is the acceleration when the displacement is 75 millimeters? So the Given data, from the given data, we can consider two cases. That is, case 1, x1 is taken as 50 mm, so that would be 0.05 meters, and v1 is taken as 12 meters per second. And the second case 2, x2 is taken as 100 mm, and that is 0.1 meters, and v2 as 3 meters per second. So the velocity vx is equal to omega under root r square minus x square. If we consider it as equation 1, substituting the values in equation 1, we will get, for the two cases, 12 is equal to omega under root r square minus 0.05 square, and 3 is equal to omega under root r square minus 0.1 square. So from this, solving equation 2 and 3, we will get amplitude r is equal to 0.1024 meters, that is 102.4 mm, and the angular velocity omega is equal to 134.28 radians per second. Now calculation of the frequency n is equal to 1 by t, that is omega by 2 pi. So that would be 134.28 by 2 pi, which will be getting as 21.37 cycles per second. And the acceleration when x is equal to 75 millimeters, that will be obtained as ax is equal to omega square x, that is 134.28 square into 0.075, that will be obtained as 1352.3 meters per second square. So coming to next problem, a clock with a seconds pendulum is running correct time at a place where the acceleration due to gravity is 9.81 meter per second square. Find the length of the pendulum, and this clock is taken at a place where the acceleration due to gravity is 9.8 meter per second square. Find how much the clock will lose or gain in a day at that place. So as per the given data, for a seconds pendulum, the time period t is 2 seconds. And it is given that the clock is running correct at g is equal to 9.81 meter per second square. So we have time period of the pendulum, that is t is equal to 2 pi under root L by g. So if we substitute the values, we will get the value of L as 0.994 meters. And for seconds pendulum, one beat is for 1 second. So we can consider number of seconds per day as 24 into 60 into 60, that is equal to 86,400 seconds, or we can say 86,400 beats. Also, the difference in the acceleration due to gravity is 9.8 minus 9.81, that is equal to minus 0.01 meters per second square. Hence, dn by n can be taken as dg by 2g. That from this, if we substitute the values, dn is equal to 86,400 into minus 0.01 by 2 into 9.81. So that will give the value as minus 44.03 beats, that is seconds. Hence, the clock will lose 44.03 seconds in a day. Coming to next problem. A vertical shaft which is 5 millimeter in diameter and 1.2 meter in length has its upper end fixed to the ceiling. At the lower end, it carries a rotor of diameter 180 mm and weight 30 newtons. The modulus of rigidity for the material of the rotor is 0.85 into 10 power 5 Newton per millimeter square. Calculate the frequency of torsional vibrations for the system. So that is given as d is equal to 5 millimeters, that is the diameter, that is 0.005 meters. And we know the polar moment of inertia J as pi d power 4 by 32, that is equal to 6.1359 into 10 power minus 11 meter per 4. Then W is equal to 30 newtons. So from this we can take the mass as 30 by 9.81. So that would be 3.058 kgs. And the radius R is equal to 180 by 2. Hence it is 90 millimeters, that is 0.09 meters. Then moment of inertia I is equal to mr square by 2. That would be 3.058 into 0.09 square by 2. So that would be 0.0124 kg per meter square. So the value of G is 0.85 into 10 power 5 Newton per millimeter square. That can be obtained as 0.85 into 10 power 11 Newton per meter square if we convert that into meters. Now we have T is equal to 2 pi under root IL by Gj, wherein this is the time period, and if we substitute the values, we will be obtaining the value of time period as 0.335 seconds. And the frequency we can get it as 1 by T, so that would be 2.985 cycles per second. So these are the important problems in the impulse momentum equation and the vibrations, mechanical vibrations. This completes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.